Hello, my name is Mr. A. Today, let's talk about nets and surface area. I suppose a good introduction would be to introduce what exactly a net is. A net is just going to be a three-dimensional shape that has been unfolded into a two-dimensional shape. Here we can see a three-dimensional pyramid that has been unfolded and is now in the shape of what can only be described as 4 flat triangles and 1 flat rectangle. Naturally, a pyramid, when you think of the pyramids in Egypt, for example, those will be much larger and, frankly, they stand up off of paper if you were to get one the size of paper. So we're going to go through and we're going to identify them. This shape is formed with 4 triangles and 1 rectangle. Pyramids are made up of more than 2 triangles, and they are identified by whichever shape is in the center of it. In this case, there are 4 triangles, more than 2, and the shape in the center is a rectangle. Therefore, it is not going to be a triangular pyramid. It certainly isn't a triangular prism or a cube, which means it is a rectangular pyramid. The next shape is made up of 6 identical squares. 1, 2, 3, 4 squares in a row, and there is 1 square located on each side. 5, 6. An important note is that this square and this square, square 5 and 6, can be moved either up or down this shape. For example, I could have replaced this and placed a square over here, and I could remove this and place a square over here. And that will still be allowed. As long as you have 4 squares in a row and 1 on each side, you will be forming what is known as a cube. Naturally, it is not a square. A square is a 2-dimensional figure. It is not a cylinder because a cylinder requires at least 2 circles. And it is not a rectangular pyramid because that is the shape we just saw before. Next up will be a triangular prism. We've already identified that if it has 4 triangles and a square or rectangle in the center, that it is called a square or rectangular pyramid. So it is not figure A. Figure D, once again, a rectangular pyramid. And figure C is made up of more than 2 triangles and the shape in the center is a triangle. This is called a triangular pyramid and is not a prism. A triangular prism is made up of 2 triangles and 3 rectangles. This is the more traditional and more common way that triangular prisms are represented, and this is going to be our answer, figure B. In this problem, we are going to talk a little bit more about cubes. Here, we have 4 shapes, but only one of them will form a proper cube. Shape number 1 has 4 squares in a row, and it has 1 on each side. This will form a cube. The problem with shape number 2 is that while it does have 4 squares in a row, it also has 4 squares in a row going another direction. That's too many squares. Shape 2 has a similar problem. While it does have 1 square on each side, it has 5 in a row. That's too many. Shape 4 does have exactly 6. However, there is no way to fold this shape that will give you all 6 sides. It does not have 4 squares in a row and 1 on each side, and it will be missing sides if we decide to fold it. That is why shape 1 is our only real option. Now earlier, I mentioned that a net is an unfolded three-dimensional figure. In this case, talking about a triangular prism, it will look like this if we were to fold it all the way up. A triangular prism has 2 triangles and is made up of 3 rectangles. So we're going to take a look at the answer choices and see which ones work. Option A contains 4 triangles and 1 square. That does not fit. Option B contains 5 rectangles. This will not fit. Option C contains 3 rectangles and 2 triangles. Option D does also have 3 rectangles and 2 triangles. However, those triangles are not the same size, and that will not work. As you can see from the original picture, those triangles are going to be the same shape and the same size, which means our final answer is going to have to be C. Next, we're going to talk about how to actually find surface area of a three-dimensional net. In this case, we are given a rectangular prism, and we are given some dimensions for it. The only difference between finding the surface area and finding area of irregular polygons is that, for the most part, finding surface area of a net is, well, the cutting has already been done for you. There is no need to cut up a shape further, as it has already been sectioned up into its different faces. This rectangle on top, for example, has a base of 8 and a height of 4. 8 times 4 is going to give me 32. The rectangle below that is, once again, has a base of 8, but this one has a height of 5, which is 40. The rectangle below that is actually going to share the same dimensions as the rectangle on top, which will be 32. And I think you can pick up on the pattern here. This 40 will be duplicated down below. Lastly, these 2 side rectangles are going to be the smallest and have dimensions of 4 by 5. 4 times 5 gives me 20. Lastly, in order to complete this problem, you're going to have to add all of these dimensions together, which is 40 plus 40 plus 32 plus 32. All of this combined will give you a total surface area of 184 square units. Looking down below, we'll find our answer of 184 square units. Now, the reason that this is called square units instead of cubic units like we would with volume is because we are not finding how much space fits inside of something, but instead we are finding the dimensions of the outside portion of a box. As a matter of fact, a good example would be this box. I just got this piece from my computer, and the way surface area would work is that a company might look at the design of this box and decide how much ink exactly do they need to cover this entire box, all 6 faces, as all 6 faces do have printing on them. So they would have to find the area of this side, this side, this side, and, well, think you get the picture. Essentially what they are doing is they unfold the box, And then they do this calculation, and they figure out exactly how much space is taken up on the surface of this box, whereas volume is what tells them how much they can fit inside of here. And that's surface area. The process is the same when finding the surface area of a square pyramid. In this case, the problem tells us that each triangle in the net below has a base of 6 centimeters and a height of 8 centimeters, represented by this image. It then lets us know by diagramming it in this picture. Using this information, we know that the base and height of this shape must be 6. The area of a square is going to be base times height, so 6 times 6. That will give us 36 centimeters. Whereas each triangle has a base of 6 and a height of 8. By contrast, we will have to do 6 times 8, which will be 48, divided by 2 because they are triangles, and the formula for the area of a triangle is base times height divided by 2, gives us an area of 24 centimeters squared for each individual triangle. It's always a good idea to label those dimensions in case you need to go back and check your work later. Lastly, as with the rectangular prism, you will need to add all of those dimensions together. 24 plus 24 gives me 48. 24 plus 24 will give me 48 again. 48 plus 48 is going to give me 96. And then 96 plus an additional 36 will give me a final answer of 132 centimeters squared. Which would be answer choice B. Another important thing I would like to point out that is very common is one of the answer choices was 96, which is what happens if you forgot to add the area of the square in the center. Another problem to practice will be this rectangular prism. In this case, however, they gave us a little bit more information, and actually something is different from this one. The base of each rectangle will be 8 feet again. However, the height of each one will actually be 3 for all of them. 8 by 3 is going to give me 24 feet squared. 8 by 3 again, and we can tell because this line will have the same dimensions as this line, which would give me 24 feet squared again. And that's going to continue all throughout the shape. The only problem is that these two shapes on the side are not actually rectangles at all. They are squares. They each have a base of 3 and a height of 3, which gives me an area of 9 feet squared. Finally, you simply have to add them up. 24 plus 24 plus 24 plus 24, as we saw from the earlier example, gives me an area of 96. 96 plus 9 will give me 105, and then 105 plus 9 again gives me a final answer of 114 feet squared. And you'll notice, once again, they gave the answer choices in case one of those shapes was not added into the problem properly. Please be careful about that. This last example is going to require a little bit of reading. In this case, they tell you the height of the shape right in the problem, but they don't actually mention anything else which you kind of need in order to solve it. If you read the problem, however, it tells you that both of the squares in the net have an area of 49 square feet. This is where familiarity with your multiplication facts will come into play. If you look at these two squares, you have to somehow figure out what the dimensions of them are. Luckily, since they're a square, each of these two lines will have to be the same dimension. Also, fortunately, 49 can only be divided by one number other than 1 and itself, and that's 7. 49 divided by 7 will give me 7. It is a square number. So, the base and height of these squares will actually be 7 feet. And that's important, because without that information, we have no way of knowing what the dimensions of this other shape is. Next, all that's left to do is to do 18 times 7. That will give you 126 for the dimensions of each of those rectangles. 126, 126, 126, and I think you get the picture. We don't really have to do any work in order to find the area of the squares, more or less told us in the problem. Those were each 49. Finally, your last step would be to add all of these shapes up, taking care to not leave any of them out because, once again, 504 is an answer, which is what you will get if you add 126 plus 126 plus 126 plus 126 and leave out the 49s. Including the two 49s, you will have an answer of 106. Sorry, I don't know why I said 106. You will have a final answer of 602 feet squared. This square pyramid has a very similar problem to that last shape we just did, in the sense that it didn't give you all of the dimensions. It did, however, tell you that this shape in the center is 49 square inches. Sound familiar? Well, it should. 49 square inches means that this shape must be a square, and that it has a base of 7 and a height of 7, which gives us enough information to figure out that the base of each of the triangles must be 7, and the height of each of the triangles must be 12. Finding the area of these triangles, we will do 7 times 12, which is 84. 84 divided by 2 gives me an area of 42 for each of the triangles. Once you know that the area of each triangle is 42 square inches, you have to add 42 plus 42 plus 42 plus 42. That will give you 84 plus 84. 84 plus 84 will give you, 168. And then you will have to add 49 square inches on top of that. That will give you a final answer of 217 square inches. And that's all that I have for surface area and nets. I'm sorry if this video is a bit late, and I'll see you later.